in today's class, first of all, we will discuss about the motion of the charged particle in a uniform electric field. So let's see what will happen if we will put one charged particle in a uniform electric field. So here in this picture, we have uniform electric field, correct? This straight line is representing uniform electric field. So in this uniform electric field, we are putting one charged particle. So we are putting one plus q charged particle in this uniform electric field, and let's suppose mass of the particle is m here. All right. So according to Newton's second law, we know that net force acting on the particle can be written as mass into acceleration. This thing we know from the Newton's second law. All right. So here, when we are putting one charged particle in the electric field, then electrostatic force is how much, everyone? It is QE. Alright, so net force is acting on this particle is QE. Only here we have electrostatic force, so it is QE, and it should be equal to mass into acceleration. So from here we will get acceleration of the particle is equal to what? It is QE by m. It is QE by m, where Q is the charge of the particle, E is the electric field, and m is the mass. So already we know that electric field is constant here, and in this constant electric field we are putting this charged particle. So E is constant here, charge is constant, and mass is also constant. So this A is constant here, everyone. So acceleration of the particle is constant if we will put this charged particle in a uniform electric field, correct? So if acceleration of the charged particle is constant, then this all three equations are valid. The first equation is what, everyone? V equal to U plus AT. Second equation is what? D equal to UT plus half AT square, and V square equal to U square plus 2AD. This all three motion equations are valid if acceleration is constant. This thing already we know, correct? From kinematics chapter, where A is constant. In this all equation, A is constant. And when we are putting charged particle in a uniform electric field, then acceleration of the particle is constant. That's why this equation is valid. This all three equations are. Let's see it. Next topic, everyone. An electron is projected with speed v in uniform electric field E. Find the equation of electron trajectory. So trajectory we want for by this electron. So what is happening here? We have one electron, everyone, and we are throwing this electron in horizontal direction. Let's suppose with v speed. So this is the electron, everyone. So definitely on the electron we have negative charge. So I'm representing with a minus q, correct? And we can write down here minus E also. And electric field is present in downward direction. So electrostatic force should be in upward direction. So if electric field is present in downward direction, then electrostatic force on the negative charge in upward direction, correct? Opposite to the electric field. This thing we know. So in this direction we have electrostatic force. And let's suppose mass of the particle is m here. We are assuming mass of the particle is m. So mass of this particle is m, charge is minus e, force is Fe, and its speed is v. And this is the displacement of the particle in x direction. Because on this particle, we are throwing this particle in horizontal direction, so it is moving in horizontal direction. And force present on this charged particle in upward direction. So due to this force, this particle will get acceleration in upward direction, so it will get some motion in the vertical direction also. So due to this force, what is happening? This particle is trying to move in vertical direction, and in the horizontal direction this particle has already velocity. And if you will look one thing, everyone, in the horizontal direction on this particle we have no any force. All right. So if we will see it, displacement of this particle in x direction. So this particle is moving in horizontal direction with constant speed. All right. So let's suppose initial velocity of this particle in the horizontal direction is what it is, v, correct? So we are writing it as v, and in the horizontal direction on this particle force is not acting. So acceleration is 0, everyone. Ax is 0. So velocity of this particle in the horizontal direction is v, and acceleration of this particle in the horizontal direction is 0. Correct? Alright. Now the next thing is what here? We know that because particle is moving with uniform velocity, so x equal to, here we will write x equal to horizontal velocity into time. Correct? So x equal to what is Vt everyone, because here acceleration of the particle is 0, that's why we can write down like this. If particle has some acceleration, then we have to add here half Vt square also. So from here time we are getting x by v, and let's suppose this is the equation number 1. Now this same procedure we will follow in the y direction also. Now look at in y direction everyone, what is happening. So if we will look acceleration of this particle in the y direction, so it is what everyone, because force is acting, so according to Newton's second law, acceleration of the particle can be written as QE, and charge on the particle is E here, so EE by m. This is the acceleration of the particle along the y direction. So acceleration of the particle along the y direction we got it here. We are throwing this particle in the horizontal direction, that's why initial velocity of the particle in the vertical direction should be 0. Alright, so uy is 0 here. Correct. Now the next thing is what here everyone, we know that y equal to, correct, now we are finding displacement of the particle in t time in y direction, so we will write here y equal to initial velocity in the y direction, then t plus half acceleration of the particle in y direction and t square. So here y equal to uy is what is the 0 everyone, so this term is getting 0 here, then half acceleration of the particle along the y direction is what it is, EE by m, EE by m, and value of t is what it is, x by v, and do it here square also. So finally see it, EEM is constant here, acceleration of the particle is constant because electric field is uniform here. Correct. Speed of the particle v is also constant. Correct, this thing we knows everyone. In the horizontal direction acceleration is not present, so v should be constant. So E, M and V, this all are constant, so we can say that V is directly proportional to x square, and this is the parabolic relation everyone. So if we will throw one particle in a uniform electric field, then this particle will follow parabolic path. Correct. So I hope this thing is clear to everyone, what type of trajectory we will get. We are getting here parabolic trajectory. So note down everyone. Let's see next everyone. An electron is projected with speed v in uniform electric field E. Calculate the time of flight, maximum height, range of the charged particle while neglecting gravitational effect. Correct. So gravitational field we are not considering here, only here electrostatic force will act on the charged particle. So let's suppose we have one electron, and we know that on the electron we have negative charge. We are throwing this electron with v speed and at theta angle with the horizontal, so it is making theta angle. Now it is doing projectile motion. So what we want everyone, we want range, we want maximum height, and we want time of flight. So how we can do it this? Let's see it. So when we are throwing one mass in the gravitational field, then this particle is doing projectile motion, correct? And we have range of the particle, we have time of flight, we have, correct, maximum height. This all things we know. But right now we have negative charge and we are throwing in the electric field. Electric field is present in upward direction, so definitely electrostatic force in downward direction. Correct? So electrostatic force in downward direction. So here acceleration of the particle is happening in the downward direction. When we are throwing one mass in the gravitational field, then on the particle we have gravitational acceleration. Correct? When we are throwing one mass in the gravitational field, Then on the mass we have gravitational force, and gravitational acceleration is acting downward action. Correct. So here gravitational force is providing gravitational acceleration. That's why it is projectile motion. Here electrostatic force is responsible for the electrostatic acceleration, and due to this, this particle is doing projectile motion. So this and this case is same. Here we have gravitational acceleration, and here we have acceleration due to the electrostatic force. So the cause of acceleration different, but both the particle is accelerating in downward action, and this both the particle is doing here projectile motion. So we want here range, time of flight, and the maximum height. Right? And maximum displacement of the particle is what? It is the range. Correct? And time spent by the particle in the air is what? It is the time of flight. So this all things we know already from the 11th class. So first of all, we are finding here time period. So time period can be written as what? If we will resolve this v in the vertical direction, so this component is v sin theta, and horizontal component is v cos theta. All right. So here time of flight can be written as 2v sin theta by g effective. We want here effective acceleration, everyone. And what is the effective acceleration? Here only we have only electrostatic force. Correct? So effective acceleration due to the electrostatic force is what? It is QE by m. Let's suppose gravity is also present. So what we will do, we will add here g with this QE by m. Then it is g effective. But right now we are not considering here gravitational effect. That's why we are not adding here g. If suppose g is also present, so add this g with QE by m. Then you will get g effective value. So time of flight is what? Is 2v sin theta by g effective. Now the value of g effective is what? Value of g effective is QE by m. So time of flight you get 2mv sin theta by QE. This is the time of flight. So first thing we got it. Now the second thing we want maximum height. So for the maximum height can be written as h max equal to, correct, u square by 2g. This is if I will take one particle, and if I will throw this particle in upward action with u velocity, then maximum height of the particle is what? It is a u square by 2g. This thing we know from the kinematics. But right now in upward action we are throwing with v sin theta velocity. Correct? So when I will write maximum height, then we need to write down here u square sin square theta, because right now upward velocity is u square sin square theta. So we need to write here u square sin square theta by 2g effective. All right, and g effective value already we know that. This is the h max. Now the next is what? Range, everyone. We want range here. So for the range, what we can do it? We know that range is equal to, third we are finding range. So range can be written as what? Horizontal velocity into time of flight. Correct? If horizontal velocity of the particle is greater, then what will happen? The range of the particle is greater, because v cos theta is the velocity in the horizontal direction. So horizontal velocity of this particle is what? It is v cos theta, and time of flight already we know that. Here we got it. Time of flight is equal to what? It is 2b sin theta by g effective. So we will multiply with this value 2b sin theta by g effective. Then we will get the range. So here we have only one difference. Correct? Here we are putting g effective value, and g effective is equal to QE by m. So I hope this thing is clear to everyone. Correct? If I will throw one charged particle in the uniform electric field, then what is the range, what is the maximum height, and what is the time of flight of the particle, and how we can find out this all things. Correct? So if anyone having doubt here, so you can put your doubt in the chat box, in the comment box. So we will discuss about that. Okay, I will give the reply in the chat box. Don't worry. Let's see it. This question, everyone. A charged particle with charge plus q mass m is released from the rest from the position x naught comma 0 in a uniform electric field E naught j cap. So electric field is present in y direction, correct? At t equal to 0, the angular momentum of the particle about origin, and we want angular momentum of the particle from the origin at any time t. So what will happen with the angular momentum? So this thing we want to know it. It will increase, correct? It will decrease, it is constant or it is 0. So electric field is present in y direction. So let's suppose this is y-axis everyone and this is x-axis. So electric field is present in y direction. So this is the direction of electric field E naught. And this is 0 comma 0. From here we will calculate all the distances. So our particle is present at x naught comma 0. So here we have one particle and the mass of the particle is m and the position of the particle is x naught comma 0. So distance from here to here is how much everyone? So we will see it is x naught. All right. Now the next thing is what everyone? We want here angular momentum, correct? So if I will write acceleration of the particle, because on this particle in upward action we have electrostatic force and this is plus q charge. All right. So acceleration of the particle can be written as q e by m everyone. Here electric field is E naught, so q E naught by m. This is the acceleration of the particle. So, and we can see it here, acceleration of the particle is constant. This is constant everyone. If I will find velocity of the particle at any t time, so it can be written as what? V equal to u plus at. What is the initial velocity of the particle? It is 0 because particle released from the rest. So initial velocity is 0. So v equal to at, correct? So acceleration is constant. So we can say that v is directly proportional to t here, correct? So velocity is the function of time everyone, and if time will increase then velocity will increase, and we know that time is always increasing, time is always moving in the forward action. So here in this case what is happening, velocity is always increased because time is always moving in the forward action. So velocity of this particle is increasing here everyone. All right, now the next thing is what we are looking for, the angular momentum. So magnitude of the angular momentum can be written as what? M, r perpendicular and v. All right, so what is the r perpendicular? See, we are throwing the particle, we are putting particle at x naught comma 0. All right, and initial velocity of the particle is 0 according to the question, and on the particle in the direction acceleration is happening, that's why it is gaining velocity. All right, so let's suppose after t equal to t time this particle is present here. Now what is perpendicular distance? So perpendicular distance is against not everyone. So we can see it here, x naught is not varying here. But what about the v? V is the function of time. So here m, x naught and v is what everyone? It is at. So a is constant, m is constant, x naught is constant. So angular momentum is directly proportional to time, and time is always increasing. So that's why angular momentum will increase here. So the correct answer should be what? It should be option number 4, increase with the time. So I hope this thing is clear. All right. Let's see next question everyone. An electron falls from the rest through the vertical distance h in a uniform electric field E directed vertically upward. The direction of electric field is now reversed, keeping its magnitude same, and the proton allowed to fall from the rest in it through the same vertical distance h. The time of fall of the electron in comparison to the time of fall of the proton is 5 times greater, equal, 10 times greater, and smaller. Which one is correct here? So let's see how we can do this question everyone. So here we have two cases. First of all, we will see case number 1. An electron falls from the rest through the vertical distance h in the uniform electric field E directed vertically upward. So in the first case, electric field is present in upward direction and we have one electron, correct? Electron has negative charge and it is falling. So definitely electrostatic force will act in down direction, Fe. All right, and it is EA, electrostatic force. So An electron fall from the rest through the vertical distance h. It is falling h distance. So this is h, everyone. From here to here, this is h. Okay, this thing is happening, and mass of the electron is me. Now see its second case, case number 2. In the first case, electric field is present in upward direction. In the second case, what is happening, everyone? In the case number 2, the direction of electric field is now reverse, keeping its magnitude same, and the proton is allowed to fall from the rest in it through the same vertical distance h. The time of fall of the electron in comparison to time of fall of the proton is. So in the second case, what is happening? Electric field is present in downward direction. All right. So now in the second case, we have proton. So on the proton, we have positive charge, and again it is falling for h height. Height is same in the second, in both cases, everyone. So here again we have electrostatic force. It is Fe. All right. So we know that acceleration of the particle equal to what? It is QE by m. Correct. So acceleration of the particle in the uniform electric field can be written as QE by m. We can see it here. Charge is E present on proton and electron. So E is same for both the cases. So we can say that acceleration is inversely proportional to mass. We know one more thing, everyone. Mass of the proton is very large as compared to mass of electron. Correct. And we can see it here. Acceleration is inversely proportional to mass. So mass of the proton is very large. Correct, as compared to the mass of the electron. So acceleration of the electron should be very less. So mass of the proton is large, then the acceleration of the proton should be less, and acceleration of the electron should be very large as compared to the proton. All right. So if you will think it, everyone, if acceleration is greater, then time taken by the electron should be very less. Correct. If something has very high acceleration, so definitely it will take less time. So time taken by the electron is very, because acceleration is very high, so time is very less. So as time taken by the proton is large, everyone, as compared to time taken by the electron, because acceleration is greater, then time is less. All right. So this thing we are getting. Now check here option, which one is correct here. So, and what he is asking here, the time of fall of the electron in the comparison to the time of fall of the proton. Correct. So time of fall of the electron is smaller as compared to time of fall of proton. The correct answer should be what? It should be smaller. All right. So this is the correct answer, everyone. Time taken by the electron is smaller as compared to the proton. So option number 4 is correct here. So I hope this thing is clear to everyone.